My name's Luke Gamasmer, and this year I was the team manager for Stratos V.
Chief of Structures.
Electronics Department.
I worked on recovery this year.
Chief of Propulsion.
Structures Department.
Project Stratos is a student initiative from the TU Delft, from a group called Delft Aerospace Rocket Engineering. The main goal really is to reuse a rocket. So we want to show students and industry that reusable rockets are achievable, they're feasible, and if they can be done by students, they need to be done by industry.
I am Jan Struzinski. This year I was chief engineer. There's a number of special things about Stratos V. First of all, this is the first time we are going to launch a bipropellant liquid-powered rocket. All of our previous rockets, they had much simpler types of engines like solid propellant or hybrid propellant engines.
Explain me the difference between solid, hybrid and liquid propulsion.
Okay, so solid propulsion has a fuel grain which has oxidizer and fuel pre-mixed and then cast in a tube with a hole down the middle. And then you stack a couple of these grains and you burn it from the inside out. Liquid fueled engines have, well, liquid fuel. Just inject the two, mix it, spark it, and then it burns, and then I get something that looks like something that looks like this, comes out the hot end. With hybrids, you're, well, right in the center. That's why they call it a hybrid. You have a solid fuel, again, cast into a grain with a hole down the middle. And you inject an oxidizer from the top, and, well, that burns with the solid fuel. The advantage of a liquid-fueled engine over a hybrid engine is primarily efficiency. The fuels that you can use in these can push to way higher efficiencies, so you just get more oomph per kilogram of propellant, which, well, you really want in rockets because every gram counts.
Secondly, this is also the first time we'll recover almost like the rocket that's that big. It's 120 kilograms of dry mass, and the recovery system involved is quite cutting edge.
Hello, my name is Nachiket Dige, and last year I was in the recovery department of Stratos V as a part-timer. So recovery is really important in any launch vehicle. Recovery is a set of functions that determines how exactly a rocket is going to land safely back on the ground. So Stratos V has a very special place for recovery in itself. It's going to be one of the first rockets of the main flagship Strate that is going to be fully recovered.
So compared to earlier rockets, we want to recover the entire thing. So that means you need to have basically bigger of everything, which makes it harder, but also the package things inside of the rocket becomes more complicated. Diameter will be roughly 5 meters.
So we have a really special initial decelerator called a balloon. A balloon is a hybrid between a parachute and a balloon.
These are our main parachutes. These are some examples, but the one we hope to at least fly in Stratos V is actually going to look a little bit like this. It's got a lot of little bits of cloth. These are called ring sails because they're just multiple rings of sails. And I think a ring sail, at least in the past, if you've seen Apollo missions as well, they've opted for ring sails for, well, its drag efficiency. So that's why we've opted to use them instead of, say, previous designs such as in Stratos 4 or Stratos 3.
So one of my favorite moments of last year was manufacturing our balloon with the rest of the recovery team. It's always nice to see what you have designed and analyzed for such a long period of time come to life.
So there's a lot of novel technologies involved. And I think what's special about this project is that it takes these different technologies, different teams in there were working on throughout the years, and then it combines them together into one project and one system.
We are a team of full-time engineers, so people who dedicate themselves for the entire year, 9 to 5, maybe even more. And we're a team of even larger part-time engineers. We're in total like something 80 engineers right now. So it's a massive team.
Successful team pictures, right?
right?
Yes,
Successful. Nice.
the start of the documentary.
Start of the documentary.
And so at the beginning of the year, I was really anxious. I was afraid that I'm gonna waste the potential of my engineers, because the role of chief of structures, chief of the department was new to me. That of course has changed over time. Now I feel more comfortable managing the team. I feel more comfortable working with certain systems within the rocket, of course. I feel accomplished in that sense that I created a team that can design pretty much any structural component.
Okay, so this is the thrust structure we built this year, and yeah, as you can see, it has been tested and all of the beams are quite bent. But yeah, this was, I guess, the main achievement of myself this year, that we had a big production crew who manufactured this and then tested it in the aircraft hall. The moment that I will remember for a long time is the compression test of the thrust structure, because I started working on it like during the winter period, and then I iterated on the design a lot of times, and finally we got to manufacture it and see it work during the test.
The moment or the experience that will forever stay with me is going to Bremen for the Space Tech Expo. With us, we wanted to take Stratos 4, and I was responsible for actually assembling the rocket after laying for 2 years in the basement. A challenge to actually find all the components, assemble the rocket here on campus, and then transport it to Bremen.
Hello.
So my name is Kubra, and I worked as a part-timer at the structure department. I think one thing I achieved was, first of all, work with different type of people, because I'm doing the masters. I was at one hand involved with a bachelor. Another thing is you have to convince companies in order to build something for you. So you have to come up with a good speech, explain to them what you did in the design and so on. So I think that was also quite interesting experience. One of the things that is really memorable to me, it's maybe not very directly connected to the technicalities, but once we had like a meeting with Airborne in their facility, and we had a nice talk. Like, we presented everything we had, and they were on board on helping us with manufacturing the IVS. And on our way back to the faculty, we dropped by the IKEA, took like a lot of hot dogs and brought that back to the team. And that was like one thing that I wouldn't forget easily. So I have to really think about my favorite machine, because there are a lot of machines I really like. Maybe the tensile bench, that's a nice machine.
The unique project to me is the people that I'm working with. As I said, I had the chance to work with very knowledgeable, amazing people, and I think we can always design the hardware for a group of engineers, but designing a hardware and having fun on the way, that's something new, honestly.
Aluminium alloy.
Oh man, I love all aluminium alloys, but my favorite one, I think, would be aluminium copper one, 2219. It's aluminium alloys frequently used in space missions. It has excellent mechanical properties. It works fantastically in cryogenic environments. And lastly, and most importantly, it's easily weldable.
You had this planned out.
For me, the biggest challenge I faced this year was definitely going into a role that I had no experience in. At the beginning of the year, I think we were all quite scared. We didn't know much. It was a new project. We had to transition from a technology development project all the way to a full rocket development project. Develop a lot of methods or kind of tools to successfully get this project off the ground. What's amazing is that you take this break in your studies and you get to do this full time for a year. And like, the recipe to a successful skill is just practice. And so when you're spending 24 hours a day, maybe not, you know, we don't work that intensely, but we work hard at what we do. And when you consistently do that for a whole year, by the end of it, you're really experts in what you do.
The proudest moment of this year was when we hot fired our engine. Looks like this. It's not this exact one. The nice one is strapped away in a box, but seeing that thing come to life again was a very nice moment.
Favorite moment? That's really tough. I think the first hot fire we did, since I was allowed to press the button, it was really exciting and I was really nervous for it. But it was really cool afterwards when everything went successfully. It was amazing, the feeling.
A moment that will forever stay with me. Probably long nights before testing and the tests themselves afterwards, particularly the hot fires. Those are the amount of work that you put into it, and then the payoff, even though it's 2 or 7 seconds long, it's totally worth it. It's great.
Rocketry is an industry it's very exclusive. Not much is known about it. I mean, it's really hard to get into, and so if you already have engineers that have had experience building rockets for 3 years, they're going to come quickly into your company and they're going to be the leaders of the next big company. They're going to be the next big engineers. They're going to really revolutionize the space. And I really can't wait to see what my colleagues and my teammates all get up to in 5 years, because I reckon you're going to see them at a lot of big companies, and they're going to be working on the next big thing. So Stratos V has 2 more years left, and come the summer of 2025, this rocket will launch, and I can't wait to see it. And I want to encourage everybody on the team, let's do this. Let's make this rocket a reality. Let's finish what we've started, and I can't wait to see this thing fly.